Welcome. Let's begin. Okay, I've collected homework 14. Sorry, I forgot to print out the paper copy for that, but I see that you must have found it online. So the next homework assignment 15 is the last, and I'll give, nice, right? Yeah. Last homework assignment. It's related to hazardous waste, which we're going to start talking about today. So I'll bring that assignment on Thursday, and this time I'll remember to bring the paper copy. Also on Thursday, we're going to have quiz 6, last quiz of the semester. So we're starting to run into a lot of lasts. Also on Thursday, I plan to talk a little bit about the format of the final exam, so that if you want to spend a little bit of your vacation time thinking about schoolwork and stressing about exams, you'll be able to stress in the proper direction. All right? Any questions before we start talking about hazardous waste? Yeah. The due date of that assignment, I don't remember. If we've got time, we'll pull up the schedule later, because it says on the schedule that's posted on Island, but I don't recall. Let's just look at the schedule, because I don't want to say yes to that if I already had something else in mind for Tuesday. Yeah. Mm-hmm. That's right. All right. And the reason why is because, why not drop one of the homeworks? It's because I thought they were all important. And the only way I could justify a gimmick like that is if I thought one of the homework assignments wasn't important. So that's why I'll keep them all. Okay, we're talking about hazardous waste management. And I haven't talked a lot about where I'm from and what my background is. I live in a place called West Virginia. It's one of the 50 United States. And historically, one of the big industries in West Virginia has been the chemical industry, and then the other aspect of it is they also have a lot of coal deposits, and so there's been a lot of coal mining. This figure shows the concentration of businesses that are registered as toxic material handlers, and usually what that means is that there's a big chemical plant there. And I don't live in Charleston. Most of this chemical valley, as it's called, is centered around Charleston. I live in a place that's called Huntington, and we've got one toxic material handler, so I feel like it's maybe a little bit more safe where I live than in this area, Charleston. But one thing that's kind of funny is there's even a town called Nitro. And so the town is named after nitroglycerin, which is, they used to make explosives there many years ago. And so you can just sort of get a sense for the dominant industry sometimes by looking at the name of the place. So obviously when you've got people who make mistakes and you've got toxic chemicals, sometimes there are incidents that arise. And I want to tell you a little bit about one that happened less than 2 years ago, just to set the groundwork for our discussion on hazardous materials. January 9th, 2014. What you're looking at is a tank farm. It is where some chemicals were being stored that were for sale to the coal industry. There was a business called Freedom Industries, and among the things that they supplied to coal producers was a chemical called MCHM. And it's a detergent that's used to wash coal. That may seem strange that you'd want to wash coal. But what it does is it helps to move away some of the impurities so that the people who are selling coal can get a higher price, because the value of your coal is partly determined by how pure it is. And if it has a lot of dust and other things that aren't going to combust, then it has a lower value, especially if it's going to be used, coal is used in the production of steel. And so in the case of steel, you want carbon and not a lot of pollutants. And so this MCHM has been used for a long time as a coal washing agent. They don't just use like normal dishwashing soap. It's a very specialized kind of a chemical. Well, so here we're looking at Freedom Industries tank farm. On the morning of January 9th, 2014, people who were driving by the road on the other side of this plant, you can see that here's a river And here's the chemical storage area. And by the way, the alarm bell should already be going off in your mind when I say we're storing chemicals next to a river, right? The reason they did that is because it's easy to bring the chemicals in on a barge, you know, like a big boat that can transfer them on and off. And so it's an economical way. Instead of having to always use a truck, you can sometimes use a barge. People started calling 911 because they smelled something very strange. They knew, you know, the human nose is so sensitive. It's a really amazing chemical detection system. Sometimes the human nose can detect things at even lower concentrations than a lot of our instruments can. We're not always sure exactly what it is. In the case of this, nobody was smelling it and saying, that's MCHM. You can smell peppermint, you can smell a lot of things, but it was just something unusual. Some people said it kind of smelled a little bit like licorice, the smell of licorice, like anise kind of a smell. And so people started calling 911. They knew this is Chemical Valley. If there's an unusual smell, it may not be the best thing, right? So that was about around 8 o'clock in the morning. At the same time, the people inside this plant realized that something was wrong. About the same time that motorists were calling 911, they also noticed something was wrong. So let me show you an overhead view so you can get an idea of the geography. The tank farm, the storage area that we're looking at is right here. You can see those circular dots are their storage tanks. And you can see here is the Elk River. The Elk River is one of the two major rivers in the area of Charleston. The other is the Kanawha River. And so the Kanawha is fed by the Elk River. And so you can see there's people living nearby this chemical plant. So that's a real problem. So think about engineering and what you've learned so far this semester about environmental engineering. Besides maybe thinking about evacuating the people living in that area, what other sort of issues would we need to worry about in the case of a chemical spill?
Stop the leaking.
Okay, stop the leaking. Absolutely. They couldn't stop the leaking immediately, and so what they did instead is they emptied the tank. So they started pumping the chemicals out of the leaking tank very quickly. Oh, relatively quickly. All right. So we've got chemicals leaking into the river. What else do we need to be worried about? The soil? Yeah. They definitely, the tank isn't floating above the river, right? People were noticing the smell from the river, but what happened is the chemical was going onto the soil, and then it pooled so much that then it went into the river. And so not only do you have the contamination in the river, but yes, there is contamination in the soil, and so that soil, we need to excavate it, make sure it's not penetrating too deeply. Remember we talked about D NAPLs and L NAPLs? Do you remember what those stand for? D NAPL and L NAPL? It's an abbreviation. Dense and light, right. So NaPl means non-aqueous phase liquid. So the question is if it dissolves into water or not. But then dense or light. So what we'd want to know is this chemical, if it gets into the soil, is it going to float on top of the water table? Or is it going to sink to the bottom of the water table? Because we'd want to start thinking about remediation. What are we going to have to do to get it out into the soil if very much has got into the soil? The other thing is, what do people drink? Water. Yeah, I mean, that's like the main thing we drink. We mix it with high fructose corn syrup and artificial coloring and call it Pepsi. Or we brew coffee with it. But, I mean, ultimately, what we drink is water. And the people of West Virginia, where do they get their water? Ooh, very close downstream. And, in fact, the water direction is from the chemical plant, and it's flowing towards the intake of the water treatment plant. And so we've got a real problem because that distance isn't very far. If you think about how wide is a road, this is an interstate highway. It's probably, I don't know, 100 meters wide. So this water is flowing approximately maybe a half meter per second. And so when there's a spill in this river, we don't have a lot of time before suddenly it's at the treatment plant. How can you tell that's a treatment plant? Well, anytime you're looking at an aerial photo and you see perfect circles all together, lots of perfect circles together, and then it looks like there's something in the middle, that's like the walkway. These are the clarifiers. So we're looking at a water treatment plant. They have to do coagulation, flocculation, because this water has a lot of turbidity. So just from the picture, we can see that the treatment plant is pretty close. And so here's a picture of the intakes. They're just sucking water right out of the Elk River. Unfortunately, if they were smart, they would have had a backup plan, but they didn't. Because we're really close to another river. They could have had a pipe to another river and saved everyone a lot of trouble, but they don't. They were just relying only on this Elk River, and probably another 500 meters downstream is the other river, the Kanawha. So they could have had like a secondary inlet at the Kanawha and just switched to that one. But since they didn't, then as they started to sample, they found out that not only is this chemical in the water, the raw water, before it's treated, but it's also getting into the drinking water as well. Because the process of coagulation, flocculation, disinfection, that's not designed for MCHM. That's not designed to remove organic chemicals. That's designed to remove turbidity, viruses, bacteria. So like the normal things that you can count on being there most of the time. And so they have the ability to mix in a little bit of our activated carbon, and that helped a little to reduce the concentrations, but not enough. And so here's just another picture of them offloading the chemicals into a barge. And it also gives you an idea of sort of what the valley looks like. It's very steep terrain. It's a pretty place when chemicals aren't being spilled into the river. So they declared a state of emergency. Actually, it came onto the news very quickly. People started getting text messages from their friends, hey, did you see the news? The state of emergency covered many different counties. You can see here's the Elk River, and then once it gets into the Kanawha River, then the Kanawha River was contaminated downstream of their convergence. Upstream of the convergence, it wasn't contaminated, and that's kind of where they should have maybe thought about putting a secondary inlet for the treatment plant, is upstream of where those two rivers join together. I live in Cabell County, and we were included in the state of emergency just because there's one little town in Cabell County that gets its water all the way from Charleston. So luckily, I wasn't forced to deal with the consequences, not directly, of the state of emergency. As soon as people heard about this, what did they do? They start rushing into the store to buy bottled water. And so within just a matter of minutes, all of the bottled water was sold out. They tried to limit quantities, but I mean, when everybody wants water suddenly, then there's no stopping the fact that it's going to sell out. All the major retailers started bringing in trucks from other states to try and resupply the bottled water. The National Guard got involved. That's sort of like the one of the military organizations in the United States started bringing water tankers to certain places and telling people, you can come and we'll fill up your water bottles. And so you can see people are bringing anything they can think of to carry water. Some people had actual water containers. Other people are bringing like big plastic organizers. Because think, not only can't you drink the water, but they said you shouldn't take a shower with the water. You shouldn't wash your dishes. You shouldn't wash your clothing with this water. They said the only suitable thing, the only thing this water is good for, is flushing your toilet. And people didn't even want to do that, because when you flush the toilet, then you would get that chemical smell inside of your house. And so people are thinking, well, if MCHM is dangerous to drink, it's probably also dangerous to breathe the fumes. And so people were just turning off the water mains at their house. They didn't want any of this contaminated water coming in. So all of the water that you need is now having to come from some outside source. You know, people who had relatives would go stay with their relatives for a while. If you could afford a hotel out of town, you'd go out of town. But this really interrupted the daily life quite a bit. Schools were canceled for more than a month. Lots of businesses had to close. Restaurants couldn't operate. because if you don't have water available to wash hands, to wash the vegetables that are going to the salad bar, then you can't operate. The health department said that all restaurants had to close. There were a handful of places that got a little bit inventive, and they tracked down enough bottled water so that they could reopen. The only problem is that Gino's Pizza is just terrible. That's like, oh, it's the worst pizza ever. The only place that is worse than Gino's is over at Matagere. There's a place there, a pizza place. It's awful also. Worse than Gino's, but maybe I'm being too picky about my pizza. Tudor's Biscuit World, that place is all right. But luckily, I didn't have to worry about, if they don't have enough water, are the employees really washing their hands? If it's all bottled water, are they really washing the vegetables like they should? So that was a calculation people had to do, So here's the bad guy. Every story needs a bad guy, right? Here he is, Gary Southern. He's just a despicable human being, just the worst. He's really, really, and one of the ways you know he's bad is that he's drinking bottled water during the press conference when there's already a shortage and other people are don't have water, and just for some reason during the press conference it's like he was super thirsty or something. It's probably all the bright lights and media attention he wasn't used to, but a lot of people said, why does this guy keep drinking so much bottled water? But one of the ways that this is a bad guy, they knew about the spill at 8:15. But they didn't call the Environmental Protection Agency until noon. So for 4 hours, they broke their legal obligation to immediately notify the authorities when there's a release of a hazardous material. In fact, they didn't call in the emergency until the police and the first responders were already there on their property. They knew that there was no way they could hide it anymore. And a lot of people think this probably wasn't the first time that they'd accidentally spilled chemicals into the river. It's probably just the first time that they'd been caught. And so another way that this is a bad guy is that obviously people are going to sue this company. And so they declared bankruptcy. They moved all of their money out of the accounts. All the top employees, the executives, paid themselves one last big paycheck. Then they closed down the company, and so that organization is now bankrupt. And then they opened a new company with a new name and it's a new business doing about the same thing, providing chemicals to the coal industry. And so that was just a really obvious attempt to evade responsibility. People were understandably freaked out by this whole situation. I mean, there are real risks of MCHM, and then there's also the psychological risks of it. Have you ever, when someone starts talking about head lice, for example, just talking about it and then suddenly you start to feel scratching on your head, just because someone mentioned head lice. You know you don't have lice, but you just all of a sudden you start to experience the symptoms a little bit. Did you have a question? Yeah? MCHM, well, it's an abbreviation for a chemical that I don't know the full name. It's methachlorohexane, something like that. But it's what they spilled. It is an organic chemical, the one that's used for washing coal. Mm-hmm. Why would they spill it? Oh, well, they didn't do it on purpose. There was a hole in their tank. Let's go. I'm glad you asked that. Because, yeah, it's an expensive chemical. You wouldn't dump it on purpose. These tanks, see the rust? Not the newest equipment. This is a really old tank farm. I think they said that the tanks had been in place since the 1980s. They're not doing proper inspections, so they just got careless. Another problem is that for a tank like this, you're supposed to have a protective barrier so that even if the tank empties, then all of the waste is contained in a protective barrier. But their protective barrier was crumbling, it hadn't been maintained or properly inspected, so there's plenty of blame to go around. That's a horrible guy with a horrible company, and the people who were inspecting, who were in charge of inspecting, weren't getting around often enough. The regulators, nobody likes regulators, right? Nobody likes the person who's enforcing the rule. Companies are always asking for exceptions. Companies are always suing the regulators for being too harsh with them. And so over time, the people who are supposed to be in charge of inspecting this, they have no incentive to do their job, because the more they do their job, the more people are angry with them. And so it's kind of a vicious cycle. It's called regulatory capture, when the industries that are supposed to be regulated are always doing a battle against the government. Yeah. Yeah, it's true. Some of the individual states have their own state division of the EPA, which is Environmental Protection Agency. Sometimes the federal government is doing the inspections, and sometimes it's state. Just like, you know, here in the UAE, we've got CWA and DWA, but then there's also FEWA, right? The Federal Electricity and Water Authority. And so FEWA is who's doing water, I think, in like Al Quwain and Fujairah. So similar to that, in the United States, the EPA, the federal agency, is doing inspections in a few states, but then most states have their own agency. And so West Virginia has its own regulator. And people don't like it when they do their job, because, you know, every state wants to be business friendly, you know, because if you're not friendly to the businesses, maybe they'll move to a different state. And so that gives an incentive for all of the regulators to lower their standards. I mean, it's a little bit like sometimes professors feel pressure from students to be relaxed and lenient and make them happy so they have good evaluations. And so then the pressure is, if you lower your standards, then you make the students happy, or you can. They're not always happy from that, but it's possible. And so regulation is sometimes somehow similar, where the people who are supposed to prevent something like this don't do their job until something big happens, and then everyone's running around in a panic. 1 month of school being missed, restaurants closed. Worst of all, we have to start eating Gino's pizza. That's probably the biggest health effect, is eating Gino's pizza. People are imagining a lot of their symptoms. You know, everyone who went to the hospital, you know, some people, maybe they genuinely experienced them. Those who are particularly vulnerable are people with asthma, because this vapor gets into people's house when they're flushing the toilet. And so if you notice some of the symptoms that are being reported, it can cause skin irritation, rash, itching, headache, sore throat. So there were, that's the range of symptoms on a percentage basis that were reported. At the end, after several weeks, they were monitoring the levels of MCHM in the river, and finally it was low enough that they thought, okay, our water is clean. You know, the river is clean. They flushed out the treatment plant, and so what they had to do is, nobody's been using the water for the last month, more than a month, and so there's still tons of this chemical in the pipes. And so they had to tell everyone to flush out their pipes. Now, not everyone could flush at the same time, because if everyone turns on their tap at the same time, the pressure would go too low. So what they did is they came up with a system where one region or one neighborhood at a time was allowed to start using water on a different day. And so they offered instructions on how you're supposed to turn on the water in your house for 30 minutes and let the faucet run and so on to flush the chemical out of the pipes. They did some research. A professor from Alabama came up to West Virginia and did some interviews and found that people were even scared to flush their pipes, because they were worried, if I flush my pipes, then the vapors from the chemical are going to get into the house. And so a lot of people were just sort of paralyzed with indecision. They weren't sure what to do, and so the chemicals stayed in the pipes for a long time. It's mostly, you know, everything's back to normal now until the next time this happens, you know, because they're still, you know, the same people are exploiting the same loopholes. They have very low ethics and a very high profit incentive. And so it's going to be interesting to see, when all the lawsuits are finished, if Gary Southern is held accountable for what he did. I'm not hopeful that he will be. All right, so let's talk about hazardous wastes more generally. What is a hazardous waste? Well, there's a list of chemicals that are known to be hazardous. And so let's pull up that list. and see what's on it. Okay, here's a list of lists. So they put together all of the chemicals that are known to have dangerous characteristics. It's 122 pages, a very small print, and every chemical they know of that's dangerous. I just saw, oh, okay, here we go. CFC, chlorofluorocarbons. These are like refrigerants that are used in air conditioning. Like R12 is a refrigerant that's used in cars in a lot of cases. So if you are dealing with one of these chemicals, then you have to go through a really long procedure of, number one, keeping records of how much of it you have. You have to keep records of how you used it, and then you have to account for how it was disposed of. And there are special companies out there that will accept leftover waste. Or, for example, if you are using a solvent, like a degreasing agent, let's say that you operate a car repair garage. Well, a lot of parts are very greasy and they have to be cleaned off before they can be repaired, and so they'll dip it into a degreaser, and that dissolves all of the oils and grease on the item. But then in the end, that chemical becomes, the degreaser gets very dirty. You can't just take that hazardous material and throw it into the sand, right? It has to be disposed of by someone who's going to do the legally responsible thing, whether it's incineration of the chemical, whether it's a hazardous waste landfill, and so on. So this gives you an idea of all the chemicals that are known to be hazardous. And it's a long list, but there's many more chemicals that exist out there that aren't on this list. It seems like, just from the length of it, that certainly this must be the list of every known chemical, right? Absolutely not. There are some chemicals that are safe that aren't on this list, and then there's a lot of chemicals that that aren't on the list just because we don't know. And so there's a second category of what's a hazardous waste. So if it's on the list, that's bad. Or if it has the following characteristics, if it's ignitable, and what that means is it can be burned. It doesn't matter whether it's highly flammable, like gasoline is highly flammable. I guess you could say that paper is ignitable, right? But I think they don't draw the line at things like paper and wood being a hazardous waste. I think that there's a higher threshold, probably a technical definition on how ignitable it has to be before it's considered hazardous. Corrosive materials. Now, let's talk about why we'd want to give these a special designation. If you think about when it's finished, when you get rid of it, when it's disposed of, why would you want to avoid corrosive materials being in a sanitary landfill? Good. Yeah, there are materials that could dissolve the plastic. We have pipes at the bottom of a landfill for collecting the leachate. And so if there's a corrosive material that got into the sanitary landfill, like an acid, battery acid, that's one of the reasons why batteries aren't supposed to go into the landfill, is because there's sulfuric acid in car batteries. And so that's a corrosive material, and it can cause damage and unwanted reactions down there. Anything that's reactive, so if it's going to go through a chemical reaction that we don't control, we have to treat that with special care. Because chemical reactions can release heat. You know, that's what an exothermic reaction is, one that's releasing heat. They can generate gases. And remember, at the end of a landfill's life, we seal it up. We weld the plastic together so that no moisture is going to get into the landfill. And so if suddenly there's a chemical reaction that you're not controlling inside of the landfill, the gases can build up, and that has the potential to pop the seal in the landfill. The fourth category of hazardous waste is toxic. Now, for obvious reasons, we have to give special care to those that can cause health hazards in humans. So let's focus on this last one for a little bit. This is a table that's in the book that's showing how toxic different chemicals are. You can see there's an item number, the constituent, the name of the chemical, and then in the third column, the regulatory level. The regulatory level can be thought of as what is the limit for the safe concentration. Okay? And so let's compare arsenic and barium. If someone told you you had to eat a spoonful of either arsenic or barium, which one do you choose to eat the spoonful of? Barium. Why is it better? Guys, don't eat a spoonful of barium, all right? Okay, so with that said, is a higher regulatory level. Yeah, so these can be thought of as indicators of how dangerous a certain chemical is. So when we see something like this, when we look at heptachlor, which is an insecticide, I believe. Heptachlor kills bugs, but it's also not great for people either. The safe level, the regulatory for heptachlor, 0.008 milligrams per liter. So I'd stay far away from heptachlor. If I was looking through a list of chemicals and like you go shopping for bug spray, I'd stay away from that one. But then there are other ones that are less dangerous, creosol. And these regulatory levels are set after doing studies on lab animals, usually mice, to find out how much of a concentration is either going to cause an acute or a chronic effect. And we've talked about acute versus chronic in the past, but just to refresh your memory, an acute reaction is something that happens in the short term, very quickly. And so if you eat a chemical and instantly have a reaction, what you're having is an acute reaction. Chronic means over the long term. And so if you are exposed to a chemical for many years and then after many, many years you develop cancer, then that would be a chronic response to a hazardous material. So sometimes when we look at lists of chemicals and how dangerous they are, those are based on chronic effects, and sometimes they're based on acute effects. So here's a table that I took from the reference manual they give you when you take the Fundamentals of Engineering exam. How many of you plan to take the Fundamentals of Engineering exam? You have to. So everyone, right? All right. So this comes from the reference manual. If you haven't already looked at the reference manual, I'd really encourage you to do that because it's got tons of really good information in there. But sometimes it's hard to use just because the formatting is a little bit different than you're accustomed to. Has anybody in here already taken the FE exam? All right, so that's in your near future. For example, they've got tables related to structural steel. Maybe you're used to seeing the structural steel tables from whatever textbook you're using or a certain code, and it can be formatted a little bit differently in the FE manual. So if you just spent a few days just flipping through page by page, and there's a PDF that you can download for free from the NCEES website. If you just go through that table, it's loaded with good information. And one of the things it has here is it's classifying toxicity of, I think these are pesticides, and the different type of warning that they have to, warning label they have to have, depending on how toxic they are. And it's measuring something called an LD50. Anybody remember what LD50 is? Because we have talked about it in the past. LD. Lethal dose. Yeah. It means the lethal dose that will kill 50% of the population. So it's expressed usually in terms of milligrams per kilogram of body mass. And so if you have a mouse or a rat, you would find out how much it weighs, and then whatever is the concentration of a chemical that kills half of them and half of them survive the exposure, that's what we call the LD50, the lethal dose in terms of milligrams or micrograms of pollutant per kilogram of body mass. And so some things are highly toxic, where even just a taste to a teaspoon of that chemical is going to kill the average size adult, then that's what we call highly toxic, and it's classified as a poison. Whereas if you need more than a pint, and so we're talking about maybe 250 milliliters of the chemical, that's still not great, but usually that is corresponding to an LD50 of 5,000. And so it's 100 times less toxic on an acute basis than this highly toxic category where it takes only a teaspoon. So LD50, that's something that's used for acute rather than chronic. This is going to be like a very short-term reaction. In fact, I think maybe even in the definition of LD50 is that not only will it cause death of half the population, but it'll do that within 30 minutes, something like that. All right, so here's another look at different chemicals and their LD50s. You can see that PCBs, and the book talks a little bit about PCBs. Those are polychlorinated biphenyls, and it's a kind of chemical that's very common because it's used in electrical transformers as an insulating agent. You know, the power poles, when the electrical wires are overhead, sometimes you'll see like a metal box up on the electrical pole, and that has transformers in it to bring the voltage down, but it also has an oil, an insulating oil. And those oils can cause cancer. They're very dangerous. But on a short-term basis, you see the LD50 is pretty high. It's not dangerous in the short term. It's just dangerous in the long term. It'll cause cancer and tumors if you're exposed to it for a long time. But it doesn't kill very quickly. Here you can see the LD50 for alcohol and how much alcohol it requires to kill the average person in terms of milligrams of this chemical per kilogram of body mass. All sorts of things. Even what's interesting, I think, is Tylenol is a very dangerous chemical. Actually, it can, you have to be very careful, but Tylenol can cause grave damage to the liver. And so the daily recommended maximum for Tylenol, they say that you shouldn't have more than, I think it's 2,000 milligrams per day of Tylenol. But then once you get to 2,500 milligrams, that's the range at which it can start to damage the liver. And, Tylenol? Oh, Panadol. Panadol, acetaminophen. Yeah, Tylenol is the brand name in the United States for Panadol over here. Same thing. Acetaminophen, yeah. So it's, I don't know about the effects it has on the brain, but it definitely, the thing it's going to ruin first is your liver. So you want to be very careful not to take too much Tylenol. Sometimes we get pretty cavalier because, for example, ibuprofen, they say take 1, but really you can take 4, right? That's not the case with Panadol. When they say 1, really, believe them, only take 1. Even more dangerous than that is nicotine. So hopefully if you're avoiding that chemical. Here's what we're going to do today for our in-class exercise. This is a table that comes from the FE reference manual, and often they'll have questions in the environmental area that come directly from this table. It's one of the few kinds of problem solving that you can do in like a 2 or 3 minute question, is looking at what chemicals can be stored together safely, or if you put a combination of chemicals together, what's likely to happen. So does everyone have a copy of today's in-class exercise? All right, good, because there's no more. Oh, one more. 10 grams of what? Oh, liver damage? Liver failure, 10 grams. I've heard it's less than that per day. Yeah, I'll take a picture of the warning label that I brought from the United States and we'll take a look. Because I think 10 grams is probably a lot. Yeah, that may be that the... Okay, so... On the back of the paper, we've got a chart of what happens when you combine 2 chemicals together. Because even if you're being really careful and you're handling the waste in a respectful way, if you store 2 different things together in the same room or the same storage closet that are incompatible, you can have unexpected reactions. So that's kind of self-explanatory. What you do is you look for the name of whatever it is in the problem statement. you follow the row to find the number of it. So esters is 14. And then you go down or up, as the case may be, and find out when you combine it with something else, what is the reaction. All right, so I'll let you get started on that, and then we'll take a look at the solution once you've started to finish it up. All right, so here's our table. So let me give you just a real quick overview. So let's say you want to find out how aldehydes behave when you mix them with, let me zoom in a little bit. All right, so if you are going to mix an aldehyde with a carbonate, so you put the aldehydes, you go over here, and then you follow it down, you can safely combine category 6 and category 9 because it's empty. But if it was 5, okay, aldehydes and carbonates. You go down, look for what is in the cell where the two meet, and then that tells you the possible thing that might happen if you mix them. Okay, let's take a look at what happens when you combine these chemicals together. Okay, if you do aldehydes and caustics, that will generate heat. So let's take a look at that. So aldehydes is category 5. We go over to the number 5 and then down to caustics, which is 10, and the letter H. Not visible there on the PDF, but heat. All right. The boss says to store cyanides and alkali earth together, and it doesn't need any special ventilation. Is that wrong? Yes. Why does it need ventilation? Flammable gases. Yeah, you don't want to be storing something if it's generating heat and flammable gases, then those flammable gases could catch on fire. So you should ventilate that area. What about isocyanates and dithiocarbamates? Yeah, we don't know. So we go over to the isocyanates. What number is that? Isocyanates, 18, right. 18, and then over to 12. 18 and 12, unknown. Okay? And last one, we have to consider all of the pairings. Okay? So you have to consider every combination. Caustics and aldehydes will generate heat. We know that from before. But nothing else will happen from the other combinations. And so the only thing we need to be prepared for in this combination would be the possibility of heat. So you'd maybe want to ventilate the room just to expel the excess heat. All right. So if you will submit your in-class exercise on the way out, I would appreciate that. Just remember that Thursday is going to be an important class because we are going to have a quiz. I'll give you the handout of the next homework assignment, homework 15, hazardous waste, and we'll also talk a little bit about the final exam. See you Thursday.